All right, we might as well begin, folks. This is a pleasure of a lifetime. Unbelievable Spannabis, something I've always wanted to come to, and my wife agreed that it was a good idea, and so here we are. What I'd like to talk about today is the updated soil food web, which most of you people probably know a little bit about, but I'm going to give you some new information. I like to call myself Lord of the Roots because I used to have a trilogy of books. Now I've got a fourth book, which I'm going to really be concentrating on today, called Teeming with Bacteria. If you haven't read my books, this is the second one you should read, not the fourth one. All of the activity that a plant requires comes from the soil, and it starts as a result of the plant putting exudates out into the soil. And that blue area are exudates, and the dots around this root are bacteria. The way the soil food web used to work in 2006, when Teeming with Microbes came out, the plant would produce these exudates. The exudates would attract bacteria and fungi. The fungi and bacteria would attract nematodes and protozoa. They ate the fungi and bacteria, pooped out the excess, and it became usable by the plant. So it's a very simple system, and it involved the bacteria and fungus, and the bigger guys that eat the bacteria and fungus, and it's known as the microbe-mediated solubilization of soil nutrients, or as Dr. Elaine Ingham likes to call it, the poop loop, because that's what it is. Now, some of the bacteria are not eaten, and some of the fungi are not eaten either, and they contribute to the nutrients for the plant. So most people know about mycorrhizal fungi. It's a symbiotic relationship between a root and the fungus, which is a mycorrhizal fungus. When it forms with a root, it forms a mycorrhiza, and that's what it looks like. And of course, it extends the root by these little hairs going out and fungi going out and bringing back all sorts of nutrients in return for getting the exudates from the plant. So the way it works is the plant puts a root into the soil. There's a zone where all the nutrients are used up. The mycorrhizal fungi are attracted. They go out beyond the zone of depletion and bring stuff back for the plant. This is known as the mycorrhizal fungal symbiosis, or the fungal loop. And of course, if you're growing cannabis, you want to use the right fungus to form that partnership, and this is what it is. They keep changing the name, but if you look for this particular name, you'll find the latest, and it is definitely worth putting on your seeds when you start your plants. Now I want to talk about the main subject here. This is a brand new discovery. It actually was made in about 2017 in Australia, and the Australians thought that what they were seeing were plants, roots, eating bacteria, and they called it rhizophagy. I'm American, I call it rhizophagy, and it's a brand new part of the soil food web, and it's part of what's known as the endophytic bacterial symbiosis. Endophytic meaning inside the plant. The bacterial loop. Okay, rhizophagy, root to feed on. And here is a root with bacteria that have been attracted to it, and you can see the root hairs up in the corner. And these bacteria are rhizophagy bacteria. They get a little smell. They smell popcorn. And the popcorn causes them to break through the cell wall of the very, very young cells that are meristem cells in the base of the root. And they break through the cell wall, and they end up in this area around the cell wall, but not inside the protoplasm, called the endoplasmic space. It's through the wall, but not all the way into the cell. The best way to think about it is to think of a tofu container. The plant root wall is the white plastic. And then you've got that water area around the tofu. That's the endoplasmic space. The bacteria go into that space and they circulate around that space. They don't go into the tofu or the inner cytoplasm of the cell. And here are some of the bacteria that are in that endoplasmic space that are circulating around the cell. Now, when a bacteria enters a root cell, the plant goes, uh-oh, I'm being invaded by a bacteria. And so it sprays the plant literally with something known as ROS. It's a reactive oxygen series, but it's called ROS. This is a way the plant protects itself, and so it sprays the ROS on these invading bacteria. This is what causes sunburn. You have a reaction. ROS in your skin causes your sunburn, and it's because of the UV rays. I even found a ROS with a sunburn. All right, so what happens, this ROS strips the cell wall off the bacteria, but it doesn't kill the bacteria. It just creates a wall-less bacteria. Now, and it eats that cell wall and absorbs those nutrients, and there are a lot of micronutrients in the cell walls of bacteria. Now, the plant is spraying the ROS. The bacteria doesn't want to get killed, and so it fights back. And it fights back in two ways. One is it creates ethylene, which it puts out into the cell, and then it creates a nitrate, which it puts into the cell. Starting with the ethylene, this ethylene causes the cell to stretch and to grow bigger, and at the same time to leak little bits of carbon to feed the bacteria that are multiplying in that endoplasmic space. So it gets a bit of carbon in return for helping the plant grow. And then, in order to protect itself even more, it produces nitrite. And it produces nitrite and sprays it on the plant, nitric oxide. It dilutes this ROS, and it makes it so that the bacteria can survive, but the nitrite turns into nitrate because the bacteria fix nitrogen inside that endoplasmic space. Up to 40% of the nitrogen your plant gets, it gets from these endophatic rhizophagy bacteria. So it's sort of trapped in a loop. If it doesn't give the nitrogen, if it doesn't give the the ethylene to the bacteria, the bacteria doesn't give ethylene to the plant, it doesn't get the carbon, and of course you've got this nitrogen loop. If it stops the nitrogen loop, it gets killed by the ROS. So it's trapped inside that endoplasmic space. And it's in that space, that little blue area there, and it's circulating around. Bacteria multiply every 20 minutes, and so you get more and more bacteria producing nitrite, going to nitrate, and producing ethylene, stretching the plant. And you get more and more, and they go round and round and round. And bacteria are very, very small. So we're talking a tremendous amount of bacteria. This is the head of a needle with the bacteria on it. So you can only imagine how small they are. So here they are, and they're circulating around. They don't have walls on them, and they still multiply, and sometimes they form these little globules of quads of bacteria. And these are all in the endoplasmic space circulating around. And there's a better picture of the quads. All right, so they're going around and around and around, multiplying and multiplying, and pretty soon you get a picture like this, where you have tremendous numbers of bacteria. It's almost difficult for them to circulate, but they're there, and they're still producing nitrite, and they're still producing ethylene. Only now they're backed up against the cell wall, and that ethylene does a very curious thing. It forms a little tube. So the big part, the wide part there, is the cell itself. Imagine that full of bacteria, and then all of a sudden, the thin little tube begins to grow. Now, you and I know that thin little tube is root hairs. And it's only growing because of the bacteria, not because it's bringing in nutrients. Root hairs are formed by these rhizophagy bacteria. Any plant with a root hair is undergoing rhizophagy, and the root hair is full of bacteria and is growing because the bacteria are producing ethylene inside that little tube, making it grow longer. Who knew? I didn't, I can tell you that. And so here they are. These little root hairs are formed by the bacteria's ethylene. And you can see some really interesting formations, but they're all full of those little spots. That's all the bacteria. And here's the root hairs with the bacteria in them. Is this news to anybody? Yeah, whoa, this is just crazy stuff. If you don't have the bacteria in your root, you don't have root hairs. Who knew? I didn't know that. And here they are. They're just absolutely spectacular. And what happens is the bacteria get into these root hairs, and then all of a sudden, a small little tidal wave comes from that endoplasmic space and pushes the bacteria up into the tip of the root hair. See all that blue stuff? That blue stuff is a dye that indicates that it's full of bacteria. And then all of a sudden, they shoot the bacteria out of the root hair, back into the soil. So here's a bunch of those little blue spots that are outside of the root. That's where an explosion occurred. And these explosions out of these root hairs can occur many times. So you can have 5 or 6 explosions as the root hair is growing. And each explosion is throwing these wall-less bacteria back out into the soil, where they take in nutrients and regrow their wall. Whew, amazing. So here's a bacteria, a root, and you can see all of the explosions that are happening. Look how many explosions occurred here. Each one of those blue little clouds is an explosion of bacteria that got thrown out there, and they're sitting there regrowing their wonderful cell walls. Why? Because in a couple of days, they're going to go back into the plant and repeat the process. Work, save, travel. They do it every 2 days. They may be in the plant for a day, out, back in again, which is really pretty incredible. It's called the rhizophagy cycle. It's definitely been proven to exist. There are all sorts of pictures on this. And I would venture to say that in the world, there are probably about 10,000 people who know about rhizophagy, and now you join that exclusive club. It's being researched by a gentleman named Dr. James White at Rutgers University. If you want to look up any of the papers, fascinating. He's got all his students doing stuff, but it gets better, folks. So what you've got, the poop loop, you got a farmer. You're putting the poop out, the exudate out there, and you're growing your stuff, and then you're harvesting it and you're bringing it in. This is more like, putting some sheep out, letting them grow the wool. You bring them back in, you take the wool off, maybe you eat a leg of lamb, and then you put them back out in the pasture again, and the following year you bring them back in again. So it's a slightly different system. Now, as these root hairs grow, with these rhizophagy bacteria in it, they create little cracks in the root itself where other bacteria, endophytic bacteria from the soil, move into the plant. They go up through the xylem and the phloem, and they move throughout the plant, and they do all sorts of wonderful things for the plant because they produce phytohormones. And eventually, they get up into the flower, and then they get caught in the flower, and they get captured in the flower and in a seed that's formed in the flower, and that seed contains the endophytic bacteria that the plant needs. And so when the seed gets put in the soil those endophytic bacteria jump off the seed and repopulate the soil with the kind of bacteria that are necessary for that particular plant. They've got corn plants that are 400 years old, the strains. They have the same exact bacteria 400 years ago that they have today. Wow, amazing. And they produce phytohormones when they're in the plant. So gibberellin, auxin, they produce phytohormones. And so they help the plant with stresses. And the plant becomes stronger as a result of having been invaded by bacteria. And so they're good for fighting off abiotic stresses, wind and too much moisture, too little moisture, or biotic stresses, all the insects and various things that eat the plants. If they didn't have the bacteria inside the plants, they wouldn't be able to survive these things. And here is Dr. White. He's up in the corner. What you're looking at, that little red and blue thing, that's a trichome. And what you're looking at in that trichome are bacteria. They're in the center, and they are out in the little red spots. They go out into the red, and they need to fix nitrogen in order to protect themselves because they're still being sprayed. And so they need an oxygen-free environment in order to be able to do the fixation. Guess where the oxygen-free environment comes from? The trichome sprays the plant with cannabinoids that enable the plant to be able to be in an oxygen-free area and fix the nitrogen. But the cannabinoids fix me and you, which is really an incredible thing. This is a discovery which is being perfected, and it's going to be perfected to the point where you're going to be able to put in specific bacteria to grow Durban poison or whatever you want to grow based upon the bacteria that are in it. And Dr. James White is the guy that is spearheading this at Rutgers University. Now, obviously, chemicals have a negative effect on bacteria, and so we need to be organic at all times if we want to make sure that we have it. And there's some obvious takeaways that work with the general soil food web. The first takeaway is you need to use mulches. The second, because they foster bacteria and they foster fungi. You don't want to rototill or disturb the soil in any way whatsoever. When you grow in a container, don't throw the soil away. That soil contains tremendous amounts of rhizophagy bacteria and some of the endophytic bacteria that kind of plant needs. Compost is phenomenal and the best thing you can use. Do not sterilize your seeds, which many of us used to do as cannabis growers. No, if you sterilize the seed, you're going to be getting rid of the rhizophagy and the endophytic bacteria that the plant needs. These are and you might want to take a picture of this, these are various existing bacteria that you can buy. The methyl bacteria is very expensive because it needs to be freeze-dried, but the bacillus up there and the aspergillium, you can buy these usually in a grow store, head store. You know, some nurseries might carry it. These are really good for adding endophytic bacteria to your system. It's unbelievable the benefits that you get when you realize what's going on. It also helps to make compost using the same plant that you're going to grow. So if you've got a large cannabis grow, you want to take the excess cannabis parts and make compost out of that. And that's the compost that'll do the best job for your cannabis plants, which is pretty incredible. Not so obvious takeaways, you need to buy the books so that you understand what's going on. And you can contact me at any time and ask questions. Happy to help in all regards. The quadrilogy is really the Bible for what goes on in the soil. And I don't say that because I wrote them. It's just I'm a reporter. I don't invent any of this stuff. I study it and write it down so that other people can read it. So I would change the order of this. I would read teeming with microbes, and then teeming with bacteria, and then teeming with fungi, and finally teeming with nutrients, which explains how once these nutrients get inside the plant, all the things that they do. All right, well, that's a real quick version. So I'm assuming there might be some questions, but I don't know. Again, if your plant has root hairs, it's going through rhizophagy. If you take those bacteria away, you're not going to have root hairs. It's just incredible to see the pictures of these bacteria-less roots trying to grow. It's mind-blowing, mind-blowing. I think, yeah.
Yeah, right here. Thank you so much. Beautiful presentation and very funny. That's great. Question, when we're using something like a soilless medium, such as like spun rock or something, how do we best facilitate these clearly important interactions?
Well, you try to add something that can hold the bacteria, which you're probably holding some fungi there, but bacteria probably not quite as much. Can you add biochar or something, charged biochar and putting it in the same system? That helps. That helps quite a bit. And then these things that I listed up there, you can also add, and they usually, I think they'll work in a hydroponic system. So, yeah, another question?
Oh, wow, thank you. You just blew my mind the way when I was teaming with microbes. I had chills. Anyway, first of all, beautiful presentation.
Thank you.
And it's mind-boggling the way. But I think we always had this argument, is it a fungal soil, is it a bacterial soil? And so I think you just solved that argument right there. It takes all of it, as we always know, because the plant uses all of it and so on. So one thing I would say, how do we scale this so that industrial, petrochemical agriculture can use these techniques to save the soil of the planet before we kill it?
Great question. Great question. It's actually two parts of the question. So when you grow, Dr. Elaine talks fungally dominated and bacterially dominated. Cannabis does best with bacterially dominated soil, but that doesn't mean you shouldn't have fungal in there as well. You need to have at least a 5%, 10% fungal component to it. Now, the question is, how can we get the big industry to use this stuff? And the answer is simple. They are not stupid, and they recognize this rhizophagy as being something which is going to revolutionize the industry. Because what they've discovered is these endophytic bacteria can have special properties depending on what kind of bacteria and what kind of plants you're dealing with. So, for example, Dr. White's working on a bacteria that sits in grass, and I don't mean cannabis, but regular grass, that jumps out and kills dandelions and then goes back into the grass again. Now, is he going to be the richest person in the world? Yeah, he is, because he's found the Holy Grail. The people from Bayer, however you pronounce them, they're looking at this like crazy. This is the answer. It's the true biological way of dealing with pests and dealing with problems. Because certain bacteria on a plant will prevent that plant from having any problems whatsoever. The trick is finding out what bacteria that is. And we're sitting on the cusp of a revolution. We all have cell phones. In about 5 years, there's already a database where every bacterium known to a person is there. We're going to be able to probably take a photograph with our phone and end up getting into that database, and it'll be telling us what kind of bacteria we have. We're going to be getting books that people like Jorge Cervantes are going to write. You know, they're going to say, if you're growing sativa, then you need this bacteria. If you're growing, autoflowers, you need this kind of bacteria. All of this research is just now beginning, and I'm hopeful that some of you here will be doing that particular research. What's really important is that we share this research, and that's the scary part. Because what might happen is you'll get a Monsanto, they'll figure out what's the right bacteria for you to grow the best whatever, and then they'll patent it. We don't want that to happen. We want people to be able to share this stuff. Sure, they ought to get some reward for what they do, but it's coming. It's going to be a gigantic revolution. It's sort of there now. You can see it. When I wander around trade shows, gardening trade shows, people have all of these things, but they don't know why it's any good. And then you can supplement all of this stuff with the phytohormones that plants need. These bacteria make the phytohormones, so we might be in the situation where we're going to be able to make indololic acid and gibberellic acid and those kinds of things ourselves, which is really very exciting.
Well, since I'm a sun grower, how does this relate to terroir? If you're putting in bacteria and so on.
I think it's what causes the terroir, but it's not in the soil. It's in the seed. And the bacteria are carried in that seed, and when it jumps out into the soil, it populates the soil with what the plant needs. That's why a Durban poison tastes like Durban poison. And it doesn't really matter where you plant it, does it? If you have a good seed, you get your seeds from Jorge Cervantes, and you plant them in the ground, they're gonna come true to whatever it's supposed to be, because of the bacteria. Because of the bacteria. It's amazing. Who knew? Who knew? And this gentleman, Dr. James White, there are YouTubes, you gotta watch him. Because he happens to be a fungal guy. He was a fungus guy before he became a rhizophagist. And so he's really into this stuff, and he loves to give talks, and he's just a terrific explainer of what I stumbled through, but he's really, really good and well worth it. Dr. James White, Rutgers University, Rutgers, for those of you who are not in the United States, and his stuff is simply phenomenal. So all of this is going on. We're all going to be part of it. We all are part of it now. You all grow plants with root hairs. Now you know why they have root hairs, and you all don't sterilize your seeds anymore. Now you know why you don't sterilize your seeds anymore. You all should be using mycorrhizal fungi. It's very, very important because it really, really helps the plant. And then there are other adjuncts that help. So for example, kelp turns out to be an unbelievable adjunct for bacteria. It helps bacteria communicate with each other. Incidentally, bacteria communicate in terpene language, terpene to terpene. But this kelp, and there are lots of different kelp products, helps accentuate the activity of the bacteria. It's really great stuff to use. So that's about it. Any other questions?
Hi,
Yeah.
I'm Naomi Robinson from Northern Ireland, and we've been growing hemp remediation studies with eucalyptus, hemp miscanthus, and what we noticed is the worm population from just the attraction to the roots of the plant is phenomenal year to year to year.
Yeah.
So the aeration improves, and we were experimenting with the live soils and doing Brix meter readings on the density of the hemp flower, the juice of that. So soil nutrition, we are doing our bit in Northern Ireland and in Wales.
Yeah,
So-
terrific. I spoke in Northern Ireland, actually. It was fun. The concept is so easy. And those worms, all they want are a couple of bacteria and a little bit of protozoa. The rest of the stuff that goes through their body, they are increasing the nitrogen, they increase the nutrient value of that soil, as well as making an aggregate that allows for aeration and water flow. It's wonderful for the structure, so you really hit on it. A lot of people freak out when they see worms because they think the worms are eating the roots. No, not unless the roots are dead. So that's a terrific example of why all of this bacterial activity makes a lot of sense. Any other questions? Yes.
Hi, just like to reiterate, thank you very much, really clear, really great. And also, sorry if the question comes across as a bit simple, but you mentioned compost, compost, compost. I was wondering, is there a particular method of composting or particular additives that would be most beneficial to promoting, all the bacteria that you've talked about so far?
Sure. Well, let's start with the kelp. That makes a lot of sense. I make thermal compost. I occasionally, or we occasionally, my wife and I make a vermicompost as well. The thermal compost should have as much of the kind of plant you're going to be using the compost on if you can. And you need to make sure that it's really compost. A lot of people make compost, but it still has a little bit of putrefaction. They don't turn it enough. You really need to turn that compost to get that bacterial component where you want it. I add green, it's like a 1-to-1 is 50-50, but you can use the 1-to-2 a bacteria or 1-to-2 fungal, and you get a different mix. So, compost is easy. It just happens. You don't even have to really do anything. You could just get it at the edges of your property. So it's the best, without question. Compost is what you want to use. It's got the full complement of what I call the bacteria and the fungi, which are the fertilizer bags, and then it's got nematodes and protozoa like crazy, which are the fertilizer spreaders. And so they open up those bags and spread the stuff out. It's the best. Any other questions? What's my favorite strain? I love land races, any kind of land race. There's that red one from Africa. What's that? From Malawi. Oh,
Malawi.
I love Malawi. Durban Poison, always a big favorite. Blue Dream, easy to grow, always a favorite. I don't think there's a strain I don't like. And what's fun is, Swami and I, we're probably not you, I'm probably the oldest guy in here, you know what I mean? When I was in high school, the idea that people would be sitting in an auditorium talking about cannabis and how to grow it blows my mind. Thank you, world, finally. Now we just got a couple of little things we have to take care of. I don't want to get too political, but you know what I mean and who I mean. Okay, sorry. Any other questions? Yes?
What about adding directly worms into the ground instead of...
Yeah, it's good. Worms are good. Directly to the ground makes sense. Now, you have to be careful. I live in Alaska. We don't have the night crawlers that go way deep, so we don't put those in the ground. You do have to be careful about what kind of worms you are using these days, because in the United States anyway, some Asian worm was imported. It wiggles much faster. It's got a different collar around us. So you have to make sure you're using good worms, not bad worms. The red wigglers are what you want, probably. Any other questions? Yes? Yeah. Right. Yeah, I always try to add worms indoors if I can, but you want to make sure you have the full complement of bacteria, fungi, nematodes, and protozoa. And if you're using compost, you have that. So even though you're indoors, you don't necessarily have all of the macroarthropods and the microarthropods. You got some in there as a result of the composting process. So works well, and which is why growing indoors is easy to do. Any other questions?
Yes, you were talking about the compost and how much like good microbes and like all sorts of different small things are in there. Wouldn't that also apply to, or even more apply to, a naturally grown soil, like a natural soil with a proper crop rotation? And yeah, wouldn't that be more natural and beneficial than using and applying compost?
Well, it's good, and obviously it works. Nobody puts compost around the redwoods. That's their own natural stuff. The reason why I suggest compost is because if it's possible, based upon this talk, if it's possible to make the compost from the same plants that you're growing, you get a benefit from that. So that's the difference. It's not, you're right, natural, very good. But if you're growing cannabis and you can get cannabis-based compost, the best.
And give thanks. I want to do another question about the flowering and growing time, which is the ratio between bacteria and fungi, which is better for the flowering time and which is for the growing time.
Right. Well, I don't do it based on flowering. I do it based on the kind of plant. If the plant is if it's a perennial, if it's in the ground for more than a year, then it likes more fungal. Cannabis is an annual, and so it's not in the ground that long, and so it likes bacterial, but it likes a good fungal element as well. I mean, it depends on what kind. Autoflowers, 90 days, not so much fungal needed. Sativa, 6 months, 7 months, needs more fungal. So it's the length of time as opposed to whether it's flowering or whether it's just growing. Any other questions? Yes.
If you augment the soil bacteria with the strains that are more commonly associated with other genetics, will that have a similar effect as the strain itself?
Good question. Is that George? Is that George? Yeah. George makes the VAP cap. Anybody used a VAP cap ever? The finest non-combustion implement you can use. The VAP cap. What booth are you in? Building 4 by the door, check out the VAP cap. I don't know the answer to that question, and we need to experiment. What if we take the seeds from a Durban poison, put it in the soil, get the plant to grow, take some of that soil, which has got the Durban poison bacteria in it, and move it over to Malawi, and grow some Malawi in it? I don't know. We need to experiment. And then we need to figure out a way to share the information. Because some bacteria do very well on one plant, but they won't do well in another plant. And I don't know if that goes from strain to strain or whether that's variety to variety. I just haven't done the research, but we need to do that. So it's a great question, George. Any other questions? Yes?
So can these root hairs, which you said that recharge
Yes.
with nutrients, can these attract the heavy metals from the soil as well?
Well, what the root hairs have in them are bacteria that can jump out of the root hair and form a conglomerate around the heavy metals to prevent them from going into the plant. So you have, I think it's pronounced cytophores, and it's a bacterial ability to be able to prevent the heavy metals from moving into the plant. Yeah. Any other one? Well, we did it. Okay, thank you very much, folks.